Have you ever really looked around and wondered how everything gets made? I mean, from the car you drive to the clean water that comes out of your tap, our entire world is built on these massive, complex, automated systems. So, what's the secret sauce? What's the invisible brain making it all happen every single second without a single mistake? Well, that's exactly what we're about to find out. Seriously, just look around you. Automation is pretty much the unsung hero of our daily lives. Behind every single factory floor running like clockwork, every robotic arm moving with perfect precision, there is a controller making millions of tiny decisions to keep the whole show on the road. So, what is this powerful little controller? What's the piece of tech that took us from clunky, manual work to the insanely efficient world we live in now? It's not magic, it's just some really, really clever engineering. You know, before the 1970s, trying to automate even a simple process was a total nightmare. We're talking about building these gigantic cabinets stuffed with thousands of electromechanical relays. Imagine the sound. And they were all connected by this insane maze of wires. They were loud, they got super hot, and oh, if you needed to change the process, you had to get in there and start physically rewiring everything. It was painfully slow and crazy expensive. And then everything changed. That entire wall of clattering relays got replaced by this. One single, compact, super tough little computer built for the factory floor. The Programmable Logic Controller. You've probably heard it called a PLC. All right, so what exactly is this game-changing device? How does it actually see what's happening in the real world and use that info to control giant, powerful machines? Let's break it down. Okay. So a PLC is basically the brain of any automated machine. Think of it as a special-purpose computer that's built like a tank to survive in tough industrial spots. You know, places with dust, vibrations, crazy temperatures. Its whole job is to read signals from the outside world, run a program that you wrote, and then decide what to do next. So the magic of a PLC comes down to this really simple but incredibly powerful loop. It's called the scan cycle, and it happens hundreds, sometimes thousands of times every second. First, it checks all its inputs, all the sensors and buttons. Then it runs through the program logic you gave it, and finally, it updates all the outputs, turning motors on, opening valves, you name it. It just goes read, think, act, over and over and over again with perfect timing. Want to make this super simple? Just think about your dishwasher at home. The buttons you push, the switch that checks if the door is closed, those are the inputs. The little computer inside, the CPU, runs the logic. It's thinking, okay, if the start button is pressed and the door is latched, then I need to open the water valve, and the valve, the pump, the heater, those are the outputs. That's a PLC in a nutshell, working right there in your kitchen. Okay, so if a PLC is a computer, how in the world do you program it? Well, you're not writing thousands of lines of code like C++ or Python. Nope. You use this incredibly intuitive visual language that was designed for the people who are already working on the factory floor. And this right here is the absolute genius of the PLC. The main programming language for it is called ladder logic, and it was made to look exactly like the electrical wiring diagrams that electricians and technicians had been using for decades. This made the jump from physical relays to a programmable computer almost seamless. You didn't need a computer science degree to automate a factory anymore. How smart is that? So you can see how this works. Let's build a really simple program together. We're going to make an automated system that fills a water tank. A ladder diagram has just a few basic parts. You've got two vertical lines, called rails, that act like the power supply. Then you have horizontal lines, called rungs. That's where your logic goes. On the left side of a rung, you put contacts, which are basically your inputs, your if conditions. And on the right, you have coils, which are your outputs, the action you want to take. Power flows from left to right, but only if all the conditions on that rung are met. So let's look at our tank. We need the pump to stop when the water gets full, right? The logic is dead simple. If the high-level switch turns on, then we need to turn the pump off. In our ladder logic program, that physical switch is represented by a contact. When the water hits that switch, the contact becomes true, which lets the power flow across the rung and energize the coil that controls our pump. It is literally that visual and that direct. Now at this point, you might be thinking, hey, wait a minute, this sounds kind of like an Arduino or a Raspberry Pi. And that's a great question because it gets to a really, really important difference. They're both controllers, for sure, but they are built for completely different worlds. A PLC, is an industrial monster. It's built to be tough, it runs on high industrial voltages, you can easily snap on more inputs and outputs as you need them, and, this is the big one, it's designed from the ground up for extreme reliability, with all sorts of safety features built right in. A microcontroller like an Arduino is awesome for hobby projects and prototyping, but you would never bet $1 million production line on one. It really just comes down to using the right tool for the job. When you boil it all down, PLCs are made to be 4 things: rugged, modular, real-time, and safe. That's why they are, without a doubt, the heart of industrial automation, and have been for more than 50 years. So here's the best part. You don't need access to some giant multi-million-dollar factory to start learning this stuff. The barrier to entry today has never, ever been lower. You can get professional-grade PLC development software from huge industry players like Beckhoff and Rockwell Automation completely for free. And these aren't some watered-down versions. They have powerful simulators that let you run a full-blown virtual PLC right on your laptop. You can write programs, test them, and figure out all your logic without buying a single piece of hardware. These controllers are the absolute foundation of smart factories, of the whole Industry 4.0 revolution that's happening right now. So learning how they work isn't just about understanding the past, it's about getting ready to build the future. So the only real question is, are you ready to start?